Welcome back. This will be part 2 of compass radial surveys. This will be the example. So let's start. The following diagram is the result of a compass radial survey. Question number A, you need to calculate the size of angle BPC. So this is the angle that you're trying to find, angle BPC. Yeah. So let's start. We need to use the information that we are given. Okay. And I know with compass radial surveys is that it relies on true bearings. So it talks a lot about the true north and things like that. So you get given the true north, you can definitely see it there. And a couple of things for me to figure out what the size of angle BPC is that from true north to the point C, it gives me that it's a true bearing of 40. So 40 degrees is there. So I can just assume straight away, because true bearings, you go clockwise. But going clockwise from true north is 40 degrees. So one step done. Now what I need to do is I need to figure out how much this is. At the moment, I don't know, but I do have enough information. For me to figure out what this particular section is, yeah, I'm going to do 360. So let's call this alpha. Okay, I'm going to find alpha, I'm going to do 360. And I'm going to minus it off of the true bearing of point B. Yeah, the true bearing of point B is 325. If I minus it off of 360, then I can figure out what this small part is. Okay, hopefully that makes sense. So 325, subtract that from 360. Okay, that should give me, if you put in the calculator, 35 degrees. So now I know that this particular section is 35 degrees. So the angle BPC is going to be just the addition of 35 degrees and 40 degrees. That should give me 75. So I know now this is 75 degrees. Okay, that's it. Question number A. Let's go to question number B. Question B, calculate the length of BC correct to 1 decimal place. I know that this angle here, BPC, is 75, so I'll just include that again. Okay, I need to find what this angle is. The line BC. Yeah. So what I'm going to do is I'm going to take this section here, this triangle here, and I'm going to redraw it. So let's redraw it exactly how it should. B, C, P. This is the angle of 75, 48 meters, 37 meters, and this is what I'm trying to find. Okay. So, yeah, this couple hints. If I want to know what the unknown side is, and I have been given 2 sides and 1 angle, that means I'm going to be straight away using the cosine rule. Okay, or in other cases, if you can see it, if you see an arrow, you use the cosine rule. Okay, so let's write this down. So the cosine rule is c squared for a missing sign is c squared equals to a squared plus b squared minus 2 times a times b times cos c. Okay, let's substitute the stuff that I know. So x squared equals to my a and b is the 2 lines that come together to make that 75. Okay, or basically, yeah. So it's going to be 37 squared plus 48 squared minus 2 times, 38, or 37, sorry, times 48 times cos my angle is 75. Put that into your calculator, and what you should get is 3002.141035. Okay, is equal to x squared. Because I want to figure out what x is equal to, what I'm going to do is to get rid of the squared, I'm going to square root it on both sides. Put that into your calculator, and you should get, if you round it to 1 decimal place, 54.8 meters. Okay, that's it for question B. Let's go to question C. You need to calculate the triangle BPC correct to 1 decimal place. So from the previous question, I know that line BC, which I found, was 54.8 meters. If I want to find the perimeter of the triangle BPC, all I need to do is add all the sides up, okay? Which you should have learned in year 7 to 10, plus in year 11. All right, so I'm going to do 54.8 plus 37 plus 48, and that should give you, if you put it into the calculator, 139.8 meters. That's it. Yeah. Lucky last question. Question D. Find the area of the triangle of BPC. So I'm looking for this. Yeah. I know that this angle BPC is 75. Okay. And I know using the area of a triangle, if you don't remember, then you take out your reference sheet out. Okay. It is half times A times B times sine C. Now the A and B, like I said in cosine rule, is the two sides that come together to make that included angle. Okay, so in this case, the two sides that come together is 37, 48, and my included angle is 75. Okay, or if not, look for a TP. So, with everything there, A is equal to half times my A is 37, times my B, 48, times sine 75, my included angle. And that, if you put it into the calculator, should give you, rounding it to 1 decimal place, 857.7 meters squared. Make sure if it tells you area, you need to have the meters squared or the squared with your units. Hopefully that makes sense about compass radial surveys. But I hope to see you soon. Bye.